Hi, this is Group 8 with Adam Kosinski, Tania Mitnasala, and Vaishnavi Narayanan, and this is our project Flappy Cat, a University of Arizona version of the popular game Flappy Bird. Problem statement. Our pilot project is a game named Flappy Cat, which runs on the desktop computer. The game will generate a 2D environment of the Arizona Stadium where players will have to dodge obstacles in order to gain points. The goal of the game is to gain as many points and travel as far as possible. The players can choose to play as one of two characters, Moma or Wilbur Wildcat. This avatar will then be used until the game is over. Obstacles are pipes, which the player needs to go between. The player will have to tap the spacebar to move their character upwards and essentially keep them flying as gravity always pulls them down. The goal is for the avatar to pass between the obstacles and also not hit the ground. Once the player hits the pipes, that is the obstacles, or falls all the way to the ground, the game is over. The game's score is computed based on how many obstacles the player is able to go through. Directions. To start the game, run the game.java file in the src folder of Flappy Cat package. This will generate the GUI of the game from where you can choose to start the game. Controls. The spacebar allows the avatar to move upwards, and this is used to fly upwards and dodge obstacles or avoid hitting the ground. The avatar is constantly being pulled down by gravity, and so the avatar moves downwards on its own. Getting into the program itself, let's go over the domain class analysis for this program. The center class is the game class, which is responsible for all the game's functionality and interacts with other classes to achieve this functionality. The game class extends the canvas class and implements the runnable class. The window class extends the JFrame class and interacts with the game class to create the GUI window that is used to play the game. The classes pipe and cat are extended from the abstract class game object, and the graphics for these classes are loaded through the graphics IO class, which in turn does this loading through the load file class. The cat class implements velocity and gravity for the avatar as it moves through the obstacles. It also interacts with the key IO class to listen for keyboard inputs using the key listener class, and the animation class to animate the avatar, essentially. Additionally, it outputs avatar and pipe coordinates to the console and states if there's a collision, in which case the game would be over. The object list class contains an array of type game object, which is the game object class, and it, along with the ground class, interact with the game class to allow for game functionality. To gain a greater understanding of how the code was created and understand the design of the system in much more detail, let's look at the class descriptions and go over the design. The flappycat.main package represents classes that have main functionality for the game. This includes the game class, which manages a game as a whole. The window class, which creates the game's window. The object list class, which contains an array of type game object class, which this class is also part of the package. This package also contains the animation class, which allows for the animation of the game, and the menu and game over classes that are key for the start and end functionality of the game. I'm going through this really quickly, but you can pause to see all the methods and such of the classes. The package flappycat.io represents the classes that are vital to the input and output features of the game. The package includes the key IO class that listens for and detects key presses, the graphics IO class, which imports the graphics of the avatars and the pipes to be used in the game, and the load file class that provides the graphics IO class with the images it loads from the files. The package flappycat.game represents the key participants in the game. This includes the cat class, which controls the output and movements of the user's avatar, Wilma or Wilbur Wildcat. The ground class, which provides a ground for the bottom of the screen, effectively acting as an obstacle and preventing the characters from entering perpetual freefall. And finally, the pipe class, which spawns pipe obstacles that the avatar needs to go through. So now let's take a look at the use case diagram. Our player is the main and sole actor in our system. The player can provide input to move the character upwards. This is done by pressing the space bar. The player can hit obstacles, that is, the player's avatar will hit one of the pipes or the ground, which are both obstacles, and this will result in the player losing the game. The player can choose to be either Wilbur or Wilmot Wildcat, and once this is done, the player is allowed to start the game. And the player can end the game, and this will display the score. So let's take a look at these use case diagrams in detail. The use cases themselves in detail. So the first use case is going to be start game. The actors are the player, it's the sole player, and preconditions is that the game executable has been opened and the system is waiting for the user to choose an avatar. So the system, as we will see later, will open a screen welcoming the player to the game, and the player will be able to click a button to choose either Wilbur, or Wilma Wildcat. Once the avatar is selected, the system will start the game. The exceptions for this use case is that the game will not start until the user chooses the character which they want to play. Post conditions are that the game will start, and on the start, and it'll take them to a new screen. The next use case is tap to fly. Again, the actors are sole actor, the player. The preconditions is that the system is currently inside a game. And the description for tap to fly essentially is that in order for our user to not hit obstacles and remain flying, the user must tap the spacebar to keep the character object flying. The exceptions for this use case is that an obstacle is hit. So if the character hits, the avatar of the character hits an obstacle that is either a pipe or the ground, the game ends, and this displays the score and an option of returning back to the home screen. The post conditions is that the system should still be in a game, and it'll wait for the user to put in his next input. The next use case for us is hitting an obstacle. Again, the player is our sole actor. The preconditions is that the system is currently inside a game. The description, we're currently inside a game and the character object hits an obstacle. This can be either the pipes or the ground. The exceptions for this use case is that no obstacle is hit, and in this case, the game will keep running as long as the player does not hit any obstacles, and the system will keep adding up the score. Post conditions for obstacle hit is that the game ends, and this will display the score, and the system will be waiting for the user's input, that is to continue back to the main menu. The next use case is score. The actor, again, sole player, or our player, sole actor or player. The precondition is that the player is not currently playing the game. The score is displayed only when the user loses the game. So once the player loses their life, the player will be shown the final screen with the score and the home button. The exception is that if the player chooses to quit his or her current game, this score does not get recorded. Post condition is that the player can choose the option to go back to the home screen or click on the X button to leave the game. Now that we have talked about our use cases, let's look at our state diagrams. So this is the start game state. And here the user goes to the home screen, and this just displays the home screen page. The user then is allowed to choose either Wilmer or Wilbur or Wildcat, and this avatar is then assigned. And once this avatar is assigned, the game begins. The next event or state is the score. So this is essentially when the score is displayed when the user loses his life or when the game's ended. So let's take a look at this. So the user is playing the game, and if the character height is equal to the obstacle height, that is if the character hits an obstacle, the character loses life and the game ends. And once the game ends, this results in the score being displayed. And it also provides an option for the user to click home, which is essentially just return back to the starting screen, which allows you to go back to gameplay. Our next event is tap to fly. So this is when the user is in the game. the user will be at a lower height and he will be falling as we have implemented gravity in our game. And the user can tap the spacebar, and this will allow him, sorry, this is mouse button, but it's supposed to be spacebar. The user taps the spacebar, and as we say here, and he will fly up. And the character will fly up and it'll go to a higher height. And once this happens, the gravity will act on it again, causing the character to fly down again. So this event is often used when the character is trying to move up to avoid the ground or to go between pipes. Then we have our hit obstacle event. And so here we have the users playing the game, and if the character height is equal to an obstacle height, the user loses his life and the game ends. And so this is what happens when a character hits its obstacle. So this is how obstacles are handled in our game. Once the game ends, as we've seen before, the score is displayed and we return back to the starting screen. So let's take a look at the sequence diagrams next. So our first sequence diagram is for the tap to fly. And so essentially this is when our character is playing the game, and it shows what happens, how the game kind of deals with our keyboard inputs. So we tap the spacebar key, and when an object is not hit, this is what happens. And so our next sequence diagram shows what happens when an object is hit, and this is how our system handles what happens when an object is hit. So tap to fly, it flies, an object is hit, and then it doesn't have any more lives because every character only has one life, and then the game is over. Now we're finally going to do what we've all been waiting for, actually look at the gameplay. So this is our starting screen where we can pick Wilbur or Wilma Wildcat as our characters. As you can see, there's the background of the Arizona Stadium. Here we're going to click on Wilbur Wildcat. You can see the little Wilbur Wildcat there. I'm tapping on the space bar, and so he's jumping. The pipes are spawning from the right of the screen and moving towards the left, and as Wilbur moves through the pipes, his score keeps increasing, and you can see that on the top right. Now Wilbur hits this pipe, and that displays a score and allows us to go back home by clicking the home button. We next click on Wilma Wildcat, and the same thing happens. I'm tapping on the spacebar, and she's jumping up and down. Gravity pulls her down naturally, but every time I tap the spacebar, she moves up. Now she hits a pipe, and the score and the main menu is displayed. And so that is our project, Flappy Cat. We hope you liked it. Yeah.